Right, today I'm going to speak about the climate negotiations leading up to Paris. 5 years ago we had Copenhagen. The whole world was very hopeful that we would solve climate change once and for all and put our planet on a path towards sustainable development. I think today hopes are much less exuberant and perhaps then more realistic. We must think of young generations for instance, in China. We have hundreds of millions of people who have been lifted out of poverty in China and Asia. And people are looking to do the same in Africa. And one of the biggest threats to their future aspirations and hopes is in fact climate change. I want to go back for a moment. We economists, we joke about what is the long run, whether it's 5 years or 10 years. Here is a real long run. This is 500,000 years. And you can see that the carbon dioxide content of the atmosphere has been moving in cycles. It's been about 280 when we have the interglacial periods, and about 200 when we've had ice ages. Now suddenly it's jumped, and oh, my diagram is a bit out of date. I've been talking about this for 25 years. Now it's 400. It was 355 in 1990. We had a jump of 50. Not in my lifetime, but in my children's lifetime, in the period of time when I've been talking about and lecturing about climate change. A change of 50 has happened before, as you can see from this diagram. It's happened a number of times, but usually that would take 1,000 years or so. Now it's happened in 30. And what that means? Well, the very short answer is that we're not quite sure. We are playing an experiment and taking a big risk with the planet. It's very likely that we will get the melting of the big Greenland and Antarctic ice sheets. This could lead to many meters, eventually as much as 60, 70 meters of sea level rise. We don't know when that will happen, but we know that we will have something like a meter or so of sea level rise just because of the thermal expansion of the oceans. That alone is enough to drown large parts of Bangladesh and of some rather valuable property around New York and Delaware and DC. We saw what the Storm Sandy did with New York. I actually lived during that time just in the dark area there in Greenwich Village in Manhattan. And it was quite an experience to see military vehicles thundering through the night in the complete darkness. You couldn't recognize which street you were on. Without the lights, Manhattan is not the same. And you didn't really know where you were. It was kind of spooky. People would gather around the generators in the day to charge their cell phones, which they anyway couldn't use because there was no reception. We know that as it gets warmer, we will have lots of these effects. But worse than that, perhaps, studies have shown recently that just a degree of warming, which we have cyclically, due to changes related to what we call El Niño, La Niña, an extra degree of centigrade actually decreases GDP very significantly in low-income countries. It doesn't have that effect yet in rich countries. But in poor countries, growth is being set back already today. We know that the rise in temperature is associated with more civil conflicts and with numerous other problems. Look at this map, look carefully. You see, when we say 2 degrees temperature, that isn't 2 degrees everywhere. That's 2 degrees on the surface of Earth. And Earth consists mainly of water. And over the water, the temperature would not rise as fast. Temperature rises faster over the poles and over land. Look at India. A 2-degree scenario actually means somewhere between 5 and 10 degrees in India and in large parts of Africa. countries where in total billions of people live in already very hot conditions, on the border of what agriculture and in fact the human body can support. These are people who work in the fields, outdoors. Another 5 to 10 degrees temperature is unimaginable. To make things even worse on this is turning into a very gloomy lecture, but climate change is only one of several large planetary environmental problems. We are facing what we are calling the planetary boundaries. This is a characteristic of that some people call of the Anthropocene, the era when humans dominate what happens on the planet. We are losing biodiversity, we are spreading toxic substance, we are manipulating the biogeochemical cycles of, for instance, of nitrogen, phosphorus and other elements. We're depleting the ozone layer of the stratosphere, acidifying not only lakes and streams, but the ocean. And in many places, water is becoming a bigger and bigger problem. Access to fresh water for drinking even, but in particular for agriculture and other purposes. Now let's go back to climate change. Climate change has a number of characteristics that makes it a really unique problem. It's very long run. It's a stock problem, not a flow problem. And it's a global problem. So, to illustrate this, I'm going to use a calculator that some close friends of mine at the University of Chalmers, Christian Nassar and Daniel Johansson, have put together. It's a calculator which you can easily find and access on the web. And it allows you to enter scenarios for emissions. And then the calculator turns this into a stock of carbon and a forecast for the temperature, obviously making the conventional assumptions about climate sensitivity and a number of other parameters. So the first piece of information is emissions. You can see, look, from 1980 to 2010, emissions have been rising and rising. We're not having a lot of success. I've been talking about climate change for several decades. It hasn't helped a lot. Emissions are rising, as you see. I mean, the concentration of carbon is rising exponentially. Because if emissions rise linearly and increase year by year, then concentration will rise exponentially. This is the characteristic of a stock problem. Temperature also rises at an increasing rate, or is forecasted to do here. If we could stabilize the emissions, and this is really difficult, but if we could really stabilize them and not stop the increase year to year, what would that mean? Well, it would be difficult to do, but it would not be enough. Because concentration in the atmosphere would then rise, not exponentially anymore, but linearly. So that's better, but it's not good enough. And we would still be on a path towards maybe 4 degrees temperature increase this century. If we cut by 1 degree, if we cut by 1% per year from 2020, we would still be on a path almost to 3 degrees. We actually have to slash emissions by 2% per year, and we should have started last year if we want to stay below the famous 2 degree target. So that is going to be difficult. Now, the fact that it's going to be difficult is a good argument why we should use market-based instruments. If you have a difficult task, you have to use the most effective instruments. Climate is affected by numerous, very different activities. For instance, the methane emissions from cows, the emissions from our cars in affluent societies, and the emissions from this guy making bricks over to the left. With so many different sources, and obviously I could throw in agriculture and all kinds of other activities, with so many different activities in so many different contexts, the cost of reducing emissions is going to be very different. And when the cost is very heterogeneous, as we say, where it varies a lot from one sector to another, then it's a very good idea to use a market-based instrument. The market-based instrument helps you choose the least cost option. One of the market-based instruments that we could use is a global cap and trade. Another would be a global tax of some sort, or globally harmonized national taxes is perhaps more realistic. But a big problem we face, particularly if we're going to use an agreement that reduces emissions, is the allocation of emissions. Who gets to reduce most? Some people suggest perhaps that we should have a method that we call grandfathering, which basically means that everybody does the same percentage emissions. Now the US has emissions per capita that are about 20 times as high as in India. So if they reduce their emissions by half and the Indians reduce their emissions by half, that means that the US still has emissions and always will have emissions that are 20 times higher. And in India, they might not think that is fair. So we have different conceptions of fairness. One suggestion is we all reduce by the same percentage. And much of the newspaper discussions, if you read about them, they are about percentages. The EU is going to reduce by 30% and maybe 40%, and the US by this percentage, and Japan, and so on. And it's all in percentages. That basically conserves the inequities we have today. Because if we reduce by the same percentage, then those who have big emissions today will have bigger, relatively bigger than the poor countries in the future too. Another suggestion completely would be that we have per capita emission, that every person on the planet has the same right to emit. This would give a completely different picture. Suppose we have a world just consisting, we just look at India and the United States. India today has 4% of emissions and the US about 16%. If they always reduce by the same percentage, then the US will always have 16% of the emissions and India always 4%. If we did a per capita allocation, India has 16% of the world's population today and the US about 4%, so you would get the opposite allocation. The difference is 12%. That's 12% of the atmosphere's ability to assimilate carbon dioxide. That is a very valuable resource, worth thousands of billions of dollars. So that's one of the reasons why the negotiations are taking time, in my opinion. There's a lot of money at stake. And so these gentlemen sit and talk and talk. This was in Copenhagen. And I'm afraid it would be maybe somewhat similar in Paris. I'm going to take an example here of gasoline. Gasoline taxes are, in my opinion, one of the few instruments that has actually had a real effect on the climate, on the carbon content of the atmosphere. Look at the diagram to your left. It has there the prices of gasoline. And you can see that Italy has always had much more expensive gasoline, and the US has had the cheapest gasoline. Now look at the diagram at the right, and you will see the consumption per capita. And, big surprise, the country where it's cheap, people use a lot. The country where it's expensive, they use much less. Much less. The difference is staggering. Look at the diagram. And it's not that you lead a bad life in Italy, or in Sweden for that matter, or in England. We Europeans, we have a nice life also. We have smaller cars, but then we have better coffee. We have a different consumption basket. We adapt. But Still, there's a lot of special interests behind gasoline consumption and taxation. And when the president of Nigeria tried to abolish the fuel subsidies, giant riots happened on the street. To understand this better, we need to understand the background. About 40% of the budget in Nigeria, a big, poor country, was being used to subsidize gasoline. In case you didn't hear that, 40% of the Nigerian budget was being used to subsidize not schools, not drinking water, not health or education, no, gasoline. You think that's what the poor need in Nigeria? If they could choose between getting proper water, health services, schools, roads, or getting cheap gasoline? No, of course not. But when you remove the subsidies, the trucking companies, the oil companies, they announced that there will be riots. And sure enough, there's lots of people who are unhappy and prepared to go out and riot. So there were riots. And the president, whose name was Jonathan Goodluck, he didn't have enough luck. And in the end, he had to back down, and a compromise was struck, and the subsidies were half abolished. They were just reduced by 50%, which is still an improvement. But it shows that we are fighting very powerful forces here. And the argument that the rioters have, they don't go out and say, "Don't touch my new Porsche." They go out and say, "Gasoline taxes are bad for the poor." Is that true? No. But that doesn't help. It's still a good argument to start a fight. And so I did some research on this. This, for instance, is the budget shares of fuels in India. I published a book on this that you can see here. It has case studies from 25 different countries. This diagram here shows the budget shares of fuels in India. And you see the poorest deciles to the left, the poorest tenths of the population, they consume a smaller share of their budget. They spend a smaller share of their budget on fuels than the rich do. This means that a tax is like a tax on diamonds or perfume. It's a luxury tax. It hits the rich. If you had a tax on food, that would be worse for the poor. If you had a tax on water, that would be worse for the poor. But a tax on gasoline is good for the poor. The state has to get its money somewhere. It's better if the state gets its money from something which is used more by the rich than by the poor. That's a progressive tax. If you care about the poor, then it's a good idea, in fact, to tax gasoline, in this case in India, and we find the same for all developing countries, essentially. Gasoline taxes are progressive in most of these countries. As a final example, I'll speak of the Swedish carbon tax. Several other large countries like France, the United States, have occasionally talked about introducing a carbon tax of usually something like $10. And they usually come to the conclusion, no, that would be impossible. It would be too tough. Sweden has a carbon tax since 1990. It's currently about the exchange rate has changed, so about $125 per ton at the moment. And the truth is, most Swedes have hardly noticed. Life goes on. It's not like Swedes wake up and think, "Oh no, I'm not going to get out of bed today. We have this carbon tax." That's not what happens. People adapt. We don't use a lot of oil to heat houses. We heat houses with wood, biomass, in various modern ways, through district heating, for instance. We use heat pumps. We use waste incineration. We use all kinds of things. And we have decoupled growth of GDP has continued, carbon emissions have gone down. And here you can see what has happened to the district heating system. District heating itself is a very good idea. It requires much less heat per house because all is burnt in one or produced in one central place. And this district heating system used to be fueled by oil in the 70s. It's nowadays fueled mainly by biofuel and waste. So carbon taxes work. The trouble is, it seems to be very hard to spread the idea. Most countries where they have tried to introduce them, it has failed. Cap and trade we have in the European trading scheme, and we have in a few more places in the world. It is spreading. There is some hope that carbon trading will catch on. But prices are low, and there are many obstacles. I think that at the moment, looking at the overall scene of the design and implementation of policy instruments, the state of international negotiations, the picture is pretty dark. And to make things worse, I would normally think of myself as an optimistic person, but it's true. We just haven't made a lot of progress in the last 20, 30 years. One thing is working better than expected. That is renewables. We're looking here at a picture of solar energy covering an old military base in Germany. The rate of expansion of wind, and even more of solar, is phenomenal. We are speaking of 50% growth per year for years and years and years in a row, starting from a very low level. But now we have reached a level that is really significant. If only this can continue for one more decade, we will have so much renewable power in the world that the power of the fossil lobby will be weakened. And that is the true issue here. Real policy making is made by lobbies. And we just have to hope that the green lobby gets stronger and the brown lobby gets weaker. When that has happened, we may get some real rational carbon pricing and some real international agreements. So that is our best hope. Thank you.